All right, I want to do a video on scientific notation. So one of my classes has already talked about it. The other one is going to hear about it tomorrow, but you might struggle a little bit, and I thought I would just do a short video on scientific notation. All right, so this starts the chunk of material on exponents, okay? And scientific notation is just a way to write really big or really small numbers so that it's really easy to see their size. It helps when you're trying to compare numbers. So like if I had a number like this, and I was trying to compare it to maybe this number, okay? It's really hard just at a glance to know which one's bigger. It sure looks like the one on top's bigger because I see the 3 as a leading digit versus a 2, but can't really tell. We talked about this in my one class, unless you put in maybe some commas to indicate the periods, so you could better tell how big these numbers were. So that's the top number and the bottom number. I'm going to mark off those. And actually, it turns out the bottom number is bigger, okay? So we have thousands, then we have millions, then we have billions, and then we have trillions. So the bottom number is 28 trillion, and the top number is only 3 trillion 170 billion, okay? I wouldn't have known that without putting the commas in. And scientific notation we're going to learn is a way to tell at a glance how big the number is. So this is called the standard notation, this form right here. And what you learn about in section 4.3 is that exponents can be used to write a number in scientific notation. They call it that because it's when you're dealing a lot of times with really small numbers like sizes of things in a cell, or really large numbers like the distance from here to the moon or the sun. Those are super big numbers or super small numbers, and scientific notation is helpful. And we used to have to use scientific notation because our calculators were so limited. So here's what this first number would look like in scientific notation. It would be 3.17. Scientific notation always has the first number being something between 1 and 10. Then you multiply, and you normally use the old-fashioned multiplication symbol that looks like an X, but it's really multiplication, times the power of 10. And you decide what the exponent on the 10 needs to be by thinking about where the decimal currently is, which is in a whole number after that, and where you want it to be, which is over here. And then you count how many places that is. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be 10 to the 12th power. And I'm making the exponent positive because this is a big number. Don't try to do it by memorizing whether you moved left or moved right. If you do that, you're going to mess yourself up. So if it's a big number, take a glance and make sure that the exponent has a positive on it. All right, now for the bottom one, you look at the significant digits, you write it so it's a number between 1 and 10. So there'll always be just one place to the left of the decimal. Then it'll be times the power of 10. And then we got the exponent, the decimal is here, and I want it to be between the 2 and the 8. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. And then do you see how that was a 12 and this was a 13? So I know this number at the bottom is bigger at a glance. It's a whole magnitude bigger, okay? All right, so what you'll see in the scientific notation homework is problems where you're just changing back and forth between standard notation and scientific notation. And then some problems where you're doing operations on numbers that are in scientific notation. Okay, before we do that, to be in scientific notation, your number has to look like this. This is going to be between 1 and 10. Between 1 and 10, including the 1. Sometimes you'll have just a 1. Okay. All right, so the A part has to be less than 10, but it could be equal to 1. And this A could be a positive or negative number, so I'm going to put an absolute value around that. So the number part has to be between 1 and 10. Then if A is negative, you would just, like if this were negative right here, you would just have a negative right there, okay? All right, and then this part right here, the exponent, I want you just thinking it's going to be positive if the number part is big, and the exponent's going to be negative if the number part is small. Okay. All right. Now I just want to go into the homework that some of you have been working on already and take a look at a couple problems. And I want to start by just looking at a couple of the basics, like number 5. All right. And I'm just going to snip a few of these and work them out. Yours will be similar, but you might have slightly different numbers. Okay. So this is a relatively small number, right? Okay. Just write it a little bigger. If I'm trying to put that into scientific notation, I look for the significant digits over here, and I'm going to write those so there's only one place to the left of the decimal. That makes it something between 1 and 10. Now I'm going to be multiplying by 10 to a power. And you see how this number is small because of all those zeros right there between the decimal and the number. So I know it's going to be a negative there. And then let me change color so I can show you. This is where the decimal started. Here's where I want it to be. So that's 1, 2, 3, 4, 5 places. So it's going to be 7.12 times 10 to the negative 5 power. All right, now I want to actually put that in to the answer for you, because that's a place where sometimes you mess up. So when you're actually trying to type it in, you get your 7.12, that's not the problem, but you need to use this old-fashioned multiplication from this palette in the tool. See, it says to use the multiplication symbol on the math palette. And then you do your 10. Don't do 7.12 raised to the negative 5th power. It's times 10, and then here's the exponent tool, and you'll put in the negative 5. Okay? And then you can check your answer and move on from there. All right, now I want to look at number 6. All right. So this one is a big number. The number part is big, but it is negative, isn't it? So when I say big, I don't, having a negative, I guess you could think of as making it small, but I'm talking about the number part is large. So ignoring the sign, you got a big number part. All right, so what I would do on one like this would be, first off, I know it's going to be negative. This makes it a negative number. Take the significant digits and have one spot to the left of the decimal. Then you're going to be multiplying by a power of 10. And you want to think about, well, here's where the decimal is right now, and here's where I need it to be, between the 7 and the 5. And then you just count how many places that is. Let me erase this little mark right here. Oops, didn't mean to do that. So we were to the point where we had this. And we said this was where the decimal is, and here's where it needs to be. And now I'm just going to count. So that's 1, 2, 3, 4, 5, 6, 7, 8 places. And so I'm going to put an 8. But if I put a positive 8, that makes the number part big, like it is. If I put a negative 8, that would be like a small number, which it isn't. So when I talk about the big or the small, I'm talking about the number part, not the positive or negative out in front. This is a big number part. So that means here you're going to have a positive 8. Okay, so you would just type in negative 7.5 times 10 to the 8th power. Okay, all right, I want to do a couple more. I'll look at number 7. Here's going the other direction. All right, so here we had a number in scientific notation, and they wanted us to change it back to standard. Okay. All right, so here's what you do on one like this. You start by writing down the first part, the 4.10. And then you think about how the 8 tells you you're going to wind up having to move the decimal 8 places, and you don't memorize whether you're going to move it left or right. What you think about is how the 8 is positive, so you need a big number. okay? So you need to make it a big. If you went this way, you're going to make the number small. So you don't go that way. Let me see if I just erase it. Yeah. So what you're going to wind up doing is moving the decimal 1, 2, 3, 4, 5, 6, 7, 8. It really helps to draw those little bins where you can throw in the zeros that you need to throw in. So in standard notation, it would be this. So it'd be 410 million. Okay. All right, so notice I didn't go just from after the 0. I went from where the decimal was. So I didn't just throw on 8 more zeros. I went from there and said that's 1, 2, then 3, 4, 5, 6, 7, 8. So don't just tack on 8 more zeros. Okay. All right, I wanted to try number 10. All right, so let's look at this one. I just picked a few from the homework that people typically struggle with. All right, so I'm trying to go to standard notation. So I'm going to write this 5.152. The negative means I'm going to have a smallish number. So I'm not going to move the decimal to the right on this one. When I move it 4 places, I'm going to go 1, 2, 3, 4 and put the decimal there. And that means I'm going to fill in these spots with zeros. So I'm going to have 0.1, 2, 3, 5, 1, 5, 2. Don't forget to include all of those. Okay. And then it is good practice when you do use the scientific notation. When you do use decimals and you're dealing with really small numbers, to have that leading 0. And so you put that in and you'll have it. All right, then you're going to have a few problems in the homework that deal with like multiplying or dividing. So let's see, I wrote down that I wanted to look at number 11. Okay, yeah, this really kind of gets at one of the hardest things with this. Okay, so the whole point of having numbers that are really big or really small written in scientific notation is that when you get ready to work on them, you have a neat way you can approach them. Okay. So if I'm trying to do this, this is 5 times 10 to the 3rd, but then it's times 4 times 10 to the 5th. So what you can do is you can put the 5 times 4, because multiplication is commutative. It doesn't matter the order in which you do it. If it's all multiplication, you can go ahead and do the 5 times 4 and get 20. And then you can work on the 10 and the 10 to the 3rd and the 10 to the 5th. And we're going to learn more about exponent rules. But this is 10 times 10 times 10 right here. And then this is 10 times itself 5 times. So you really have 1, 2, 3, 4, 5, 6, 7, 8 tens all multiplied together. So this is times 10 to the 8th power. All right, now after you've done all of that work, you're feeling pretty good about things. But if you put that in as your answer, you'd be incorrect. This is kind of in between. It's not scientific notation, and it's not standard notation. The problem is the 20 right here. It's too big. It's not between 1 and 10. See, I would need to think about this. I'm going to show you 2 ways to think about it. The 20, just the 20 by itself, could be written as 2.0, and then you would have to have 10 to the 1st power just to get the 20. Then you already had the 10 to the 8th. So when you put these guys together, you really wind up with 2 times 10 to the 9th power. So that's one way to like logically think your way through it. Okay, here's another way to do it that's a little bit of a shortcut, but I think you can consistently use this idea and it will work. See, I need to make 20 smaller. 20 is too big. It needs to be between 1 and 10. So I'm going to move the decimal 1 place to make it a 2. And so since I made that smaller by 1 place, then that means to compensate for that, I'm going to have to add 1 over here to the exponent. And so that's going to become 10 to the 9. So that's a shortcut that I use a lot. Smaller by one place. So let me add 1 to the 8 to compensate. Since I made this part of the number smaller, I need to take the number of places. I took away 1 place here, so I need to add 1 to the exponent. All right, I want to do one division problem, and then that's all we really need to look at here. You can work through the rest of the issues as you're doing your homework. All right, so I want to go to one that's a division. That's a good one. Okay. I've already worked it, so let me see if I can get a similar problem. All right, so here's one that I wanted to look at with you. I'm going to go ahead and snip this one. This one wants the answer in both scientific and standard notation. Let me show you how to think about it. All right, so when you're doing the division problems, when you want it in scientific notation and it's starting out that way, what you can do is just take this and cut it. So you deal with the number part and the power of 10 part. So you can do 8 divided by 2, and that's 4. And then here we'll learn again more about exponents, but I kind of like you to know one of their uses before we get too much into it. But when you have like these two exponential expressions that have the same base, it turns out you can take the exponents and subtract them when they're like this. So this would become 10 raised to the -6 minus -3. And so that would be 4 times 10. And -6 minus -3, remember, is -6 plus 3. So you wind up having just that. 4 times 10 to the -3 would be your answer to part A. Okay. And then for part B, you're putting it in standard form. So you're starting with the 4 that has an understood decimal here, and you're trying to have a small number. So you're going to move it 1, 2, 3 spots. And so your answer to part B would be 4 thousandths is what that would be. And you can put the leading 0 there. That has the same meaning, just for good practice. Okay. All right. All right, and then I'm going to jump near the end. There's a couple word problems. I'll just talk about the operations on those. So let me go back to the assignment itself. We're not going to work them through all the way. Okay. I want to go to like number 18, I think it is. I'll just move using the arrows. Okay, 19. All right, 19 and 20. Let's just talk about the setup on this one. All right, so on 19, it's telling you how much on average they collect from people. So the government collected about $6,140 per person, and there were 260 million people. Okay. And so you ultimately want to use scientific notation, or at the end, scientific notation. So take your 260,000 people, million people, I should have said, 260 million people, and then multiply that by 6,140. And if you want to just do that on your calculator, you can, because your calculator can handle that. But this is what I wanted to tell you. You would multiply and then change to scientific notation. Okay. All right, and then the last one, well, it didn't make it clear whether it wanted the answer in scientific notation or not. So I think I'm going to grab my calculator and work that one out more fully. But let's set up the next one, and then I'll come back to it. Okay. All right, so now the next one starts out with a number in scientific notation that represents the debt of some country. Okay. and that's 4 times 10 to the 11th. So that's like 4 with a whole bunch of zeros after it. And the country has a population of 200 million people. And it says, how much will it be for every man, woman, and child in the country? Okay. So if this is the debt and you have 200 million people, you could take this and divide it by the people. But you need to kind of think about how to write that. So you can either change the top one and put it in standard notation. So the decimal is there and it needs to be a big number. So I'm going to move it this way. That's 3, 6, 9, 10, 11. And then 200 million is 200 with 1, 2, 3, 4, 5, 6 zeros. And you may not have known that. Okay. So there's both numbers written out. And you can just divide that right there to get your answer. Okay. All right. I'll talk about which form they want number 19 in next time so that the video doesn't keep going forever. So let me go ahead and just stop sharing this. Actually, let me go ahead, if you don't mind, let me just back up to that previous snip for a second. Let me go grab a calculator and see which way they want the answer on this one. Let me grab my phone real quick. All right, so I'm just going to take a second, and your numbers will be different, but I'm going to take a moment, and I could just use my calculator and type in 6140, and I want to multiply that by 260, and then 1, 2, 3, 4, 5, 6. So I could do that, and that gives me 1,596,400. Then 1, 2, 3, 4, 5, 6. So you could have done it that way. And then what I'm trying to do is go back and make sure I can tell. It looks like they want it in scientific notation, but I don't know if they want you just using scientific notation. Okay. Or if they want you to do the operation, or if they want the final answer that way. And then this would be 10. How many places did we move it? That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would be 12 places, and it's a big number, so it'll be a positive 12. Okay, so let's try that. I'm also looking at this rounding to the nearest hundredth as needed. So I'm kind of curious about this. No one's ever really asked me about this question before. So I'm going to go in here and go back to number 19 and try entering the scientific notation. So I'm thinking they might want me to round that 1.596 that I had. I'm going to round it to 1.60. It said round to the nearest hundredth. And then I'm going to use the math palette and then make that 10 to the 12th. And see if that's what they meant, okay? But, you know, we just have to sometimes redo it. So, yeah, that's what they meant. So round that first number part, which was here. So this part right here, if I rounded to the nearest hundredth, that would be to the second spot. So that 6 would make the 9 turn into a 0, and that would make the 5 turn into 6. So it'd be 1.60 times 10 to the 12th. Okay. All right. So that's more than enough on scientific notation. It's intended to just be something that shows you one of the uses of, oops, I want to just stop sharing. One of the uses of